In question 9, a geometric progression is such that the second term is equal to 24% of the sum to infinity. We have to find the possible values of the common ratio. Now, the nth term of a geometric progression is given by a r to the power n minus 1, and the sum to infinity is given by the formula a divided by 1 minus r. So the expression for the second term would be a r to the power 2 minus 1, so that the second term will be written as a r, and the expression for sum to infinity will be a upon 1 minus r. Now, as the second term is equal to 24% of the sum to infinity, so we can write this as the second term will be equals to 24%, which can be written as 0.24 into the sum to infinity, which is a upon 1 minus r. Now, simplifying this, we'll get ar is equals to 0.24 a upon 1 minus r. A and A can cancel out, as if I bring this A on the left hand side, it will cancel with the A. So A and A will cancel. Cross multiplying, we'll get R minus R squared is equal to 0.24. Making R squared term positive, so we'll bring it on the right hand side and write it as R plus R squared minus R plus 0.24 equals to 0. Now we can use our calculators to factorize this, or we can just multiply the whole term by 100 to get rid of the decimal. So this will become 100r squared minus 100r plus 24 equals to 0. Dividing it by 4, we will get 25r squared minus 25r plus 6 equals to 0. Now using middle term breaking, so that will become 25r squared minus 15r minus 10r plus 6 equals to 0. Now taking 5r common from over here, so we'll get 5r minus 3, and taking 2 common, so this will become 5r minus 3 equals to 0. Simplifying, we'll get 5r minus 2 and 5r minus 3 equals to 0. So the two values of r will be equals to 2 upon 5 and r will be equals to 3 upon 5. In part B, it says that an arithmetic progression P has first term A and common difference D. An arithmetic progression Q has first term 2A and the common difference D plus 1. It is given that the fifth term of P upon 12th term of Q is 1 upon 3, and the sum of first 5 terms of P divided by sum of first 5 terms of Q equals 2 upon 3. We have to find the value of A and the value of D. Now for P, first we can make an expression for the fifth term and the sum of 5 terms. So for P, as it is an arithmetic progression, so the nth term is given by A plus n minus 1 into D. So the first term is A and the common difference is D. So the fifth term will be n minus 1. So that will become 5 minus 1, which is 4. So the fifth term will be A plus 4D. And for the sum of first 5 terms, the sum for n terms of a arithmetic progression is n upon 2 into 2A plus n minus 1 into D. So for the sum of 5 terms of this arithmetic progression, this will become 5 upon 2 into 2A plus 5 minus 1. So that will become plus 4D. Now for Q, the expression for the fifth term will be, so that will become as A is 2 into A plus 1. So in place of A, we will write 2 and bracket A plus 1. As it is the fifth term, so that will become 4, and D is D plus 1. So we'll write D plus 1. So that becomes A plus n minus 1 into D, and in a place of A, we had to write 2 into A plus 1, and in place of D, we had to write D plus 1. And for the sum of 5 terms for the progression Q, that will become 5 upon 2 into 2, and the first term is 2A plus 2, or we can write 2A plus 2 in place of the first term, and the sum of first 5 terms, so n minus 1 will become 4, and the common difference is D plus 1, so we'll write D plus 1 up here. Now, once we have these expressions, we have to make equations and then solve them simultaneously. So first, we have to divide the fifth term of P and the 12th term of Q. So this should have been, we should have found the 12th term. So this will become, the 12th term will be equals to 2 into A plus 1 plus 12 minus 1, which is 11. So that will become 11 into, and D was D plus 1. Now, once we have these expressions, now we can form the equations. So the fifth term of P will be given by A plus 4D. And the 12th term of Q will be given by, so we can simplify this to write it as 2A plus 2 plus 11D plus 11 equals to 1 upon 3. So simplifying this, we can write this as A plus 4D, and this will become, so 2A plus 11D, so that will become 2A plus 11D, and 11 plus 2 will become a 13 equals to 1 upon 3. Cross multiplying, we'll get 3A plus 12D equals to, so that will become 2A plus 11D, and 13 times 1 will become 13. We can bring the 2A and the 11D on the left hand side, so 3A minus 2A will become A, and 12D minus 11D will become D, and 13 will be left on the right hand side. So this will be A plus D equals to 13. For the other expression is the sum of first 5 terms of P divided by the first five terms of Q. So the sum of the first 5 terms of P was given by 5 upon 2 into 2A plus 4D, and dividing it by the sum of the first 5 terms of Q. So that was 5 upon 2 into 2 into 2A plus 2 plus 4 into D plus 1, and that is equals to 2 upon 3. Now first we can cancel out the 5 upon 2 to simplify. So this will become 2A plus 4D in the numerator, and this will divide by, so this will become 4A plus 4 plus 4D plus 4 equals to 2 upon 3. Cross multiplying, we'll get 6A plus 12D, and 2 multiplied by 4A will become 8A. 2 multiplied by 4D will become 8D, and 4 plus 4 is 8, so 8 times 2 will become a 16. Simplifying this, bringing 8A on the left hand side, we'll get 6A minus 8A, so that will become minus 2A. 12D minus 8D will become a plus 4D, and that will be equals to 16. Now, once we have the two equations, now we can solve them simultaneously. So the first equation was A plus D equals to 13. And the second equation is minus 2A plus 4D equals to 16. So we can multiply the first equation by 2 so that the A terms are equal. So multiplying the first equation by 2 and the second equation by 1. So this will become 2A plus 2D equals to 26. And this will become, so this will remain minus 2A plus 4D equals to 16. So 2A and 2A will cancel out. 6D will be equals to 26 plus 16, which is 42. So D will be equals to 7. Once we have the value of D, we can now substitute this into one of the equations to find the value of A. So A plus, as the first equation is A plus D equals to 13. So we can write it as A plus 7 equals to 13. The value of A will be equals to 6. So the final answer will be A equals to 6 and D equals to 7.